Let's take a stone. First thing that we will do is measure its mass, m. For that we use a beam balance. Now we know the mass. Let's call it m. Now let's raise it to a height h. Now at this point, the stone has acquired potential energy. You agree with me? And what is that potential energy? mgh. Now let me ask you a question. What is the kinetic energy of the stone at this height? Well, at the highest point, the velocity of the stone is 0 because it is at rest. So there is no kinetic energy at the highest point. Now we do something. We release the stone and the stone falls freely under gravity. And when it is falling, its velocity and therefore its kinetic energy increase gradually. Let me ask you a question. How is it gaining this kinetic energy? I'll come back to it later. Now let's do some maths in physics. Suppose the velocity of the stone is v just before it hits the ground. What will be the kinetic energy? Half mv squared. But what about the potential energy? Well, we are talking about a scenario where it is about to touch the ground. So the height is 0. So height is 0. That means the potential energy is 0. So there is something that we can conclude from this. Well, according to the law of conservation of energy, the total energy of the stone remains constant before and after the drop. So what are we talking about? Yes, the kinetic energy plus the potential energy remains constant, or half mv squared plus mgh is a constant. So what actually happened was, and that was the question I asked you, when we dropped it, the potential energy of the stone started getting converted into kinetic energy. So the moment it touched the ground, all we had was the kinetic energy in the stone. So at any point in its path, the total energy would remain constant.